Okay, so one of the things when we say cyber physical system, we have talked about physical attacks, we have talked about cyber attacks, but then there are also dependencies. We're talking in more detail. But try understand, there might be possible I can perform a physical attack, but then can impact the physical cyberspace, or the other way, I may perform a cyber attack that can influence the physical space. You have certain policies for cyber, how you handle cyber attack, certain policy how you handle physical attack, but they might be interlinked. So when we design policies, we also need to make sure we understand both policies and how an attacker can utilize those. Because generally, in an older system, when we say physical security, it means simply tampering. And you have guidelines how not to tamper the physical devices. In cyber, generally we say how to protect data over the communication. But now what we are saying is, you not just have to protect data. Protecting data is not necessarily as much as protecting the physical system. I'll be talking about in some slides how it's different. Okay, so if we look at this figure, unfortunately this doesn't work on the screen. Okay, you see critical infrastructure. There are a lot more attacks being targeted on CNI compared to other non-CNI sectors. And if you look at the biggest threats to organization, you see social engineering on the top, insider threats, advanced persistent threat. What is advanced persistent threat? Quickly. What is APT?
It's like it stays like when it have occurred, it stays for like for a long time.
Right.
For a long time.
Okay. So when there's a traditional virus in the system, we have IDS or antivirus. Yeah, your antivirus can check, say, oh, these files have been infected, and they will put into quarantine or whatever, remove it from the system. So it's easier to detect those kind of attacks or malware, I would say, in the system. Well, now what is advanced persistent threat? It takes time to execute. So in a very simplistic way, it gets into your system. So your IDS should not detect it because there's no malware ideally. So it looks for bind. How does the antivirus work? What it detects saying there's a virus, what does it mean? So it looks for signatures in a simplistic way, patterns of strings. No, it looks for, so for all the virus, it's a code. So kind of string it matches, saying it could be this kind of virus, remove it, remove those files. Now in this case, as I said, attackers inject simple files in the system. It doesn't have any symptom of those strings. So whenever IDS will check, saying everything looks fine. But what it does, since your system is connected to the internet, it will connect to the internet and download the latest version, yeah, which has malicious content in it.
Sir, can we take Pager's attacks as an example of last time? Pager's attacks on Hamas. Can we take this as a PT attack?
Pager's attack, what happened? What was that?
I mean, last time this kind of attacks was occurred, like Pager's attacks between Hamas and Israel.
Maybe yes, because those kind of attacks are now being more popular. Popular in the sense they will bypass your IDS, traditional IDS. So intrusion detection system cannot detect them. And once they get into system connected to the internet, they will load, fully loaded with malware. And then malware has certain conditions to execute. It will not execute on the go. It will look for the target device, which kind of device it needs to target. Sometimes you have your device is connected to the whole network. Yeah, so let's say in this university, I have my laptop connected here. But as an attacker, I want to target a server where the financial data is there in the university. So maybe this is the easiest system I can get into because it doesn't have IDS, for example. So attacker can get into the system, or maybe you have basic IDS, intrusion detection, whatever, antivirus. It will get into systems, sit there. It will say if this device is connected to the network, maybe that attack can propagate to other devices. It will kind of load it, start propagating until it reaches to the destination, which server it's targeting, and there it will start harming. So even if it's going through other devices, it is very difficult to detect. Once it gets to target, start executing, triggering, and then harm that device. And that's why these systems, these attacks are really difficult to detect. Right. Then we got what, unpatched system, malware, DDoS, ransom. We know ransom, yeah, ransomware attack. Then got mobile malware and others. Okay, in OT system or cyber physical system, there's a popular model called Purdue model. In IT system, we have something called TCP/IP. We have OSI model. I guess all of us know that, yeah? OSI, TCP. So in OSI, for example, we have 7 layers, physical, data link, up to application. Similarly for OT system, so the way it looks like, this is your communication layer. This is your basically physical and operational, and this is DMZ. What is DMZ? What is DMZ? DMZ sometimes people call it. It's a demilitarized zone. What does it mean? And it's a link between IT system and an OT system. I'm calling this OT system, and I'm calling this an IT system. So generally in, for example, power plant, for example, they have some part of IT system because they need devices, people who look for monitoring certain things. But then they also have physical operations, a lot more complex power devices, communication devices, and so on. So they have 0, 1, 2 label. We call this Purdue model. 0 label means we are talking about field devices, sensors, actuators, all those comes here. Then you got controller of these devices. Yeah? So sensor will sense data, send it somewhere, and we want to control what data we want to collect, how long we want to collect, and so on. So you got a couple of devices. Then you got HMI or supervisory label, where you control these controllers. Yeah? HMI is human machine interface. As a human, you can set, reset things. And then you got control center. So let's say this is example. Now if I'm picking an example of smart grid, particularly let's say substation. So on substation, you got sensors, you got devices that sense power measurements, you got supervisory control which says what value should be capturing, what is the level of those values, whether everything looks okay or not. If not, you control, up, down voltage, current, whatever. Then you got operational management, where you got human machine interface, application server, database server, but they all are part of the system. You're collecting data, maybe storing somewhere, doing some analysis, and so on. On enterprise zone or IT zone, I have domain controller. What is the role of domain controller? Domain controller is the one that caps all the credentials. Now we are talking about centralized systems. I don't know if it does it. So when you go to your university website, what protocol it use? So for example, when I use my laptop, which is the university laptop, if I connect here, I'm connecting to the centralized system. Again, they have divided the centralized system in 2 parts. I might not need to log in to certain part of the system once I'm logged into one website. So university have their own subsystems within that. Yeah, some systems force you to log in again and again, but some systems may not. I'm not sure how does it work. But so that is the concept of something called Active Directory. What is the role of Active Directory? So let's say if I have a system here which is not connected to my centralized server, centralized system here. If this is kind of compromised because it doesn't follow strict policies that university follow in terms of securing your system. Let's say we have, your system should be updated in every week or every month. You should be using strong password which looks XYZ. If my system is connected to centralized, we have a centralized policy that will enforce every other system. Even if I don't upgrade my system, the centralized system enforce it to restart. It will say there's a time to patch. It will give you a time saying few days if you want to do now or tomorrow or day. But at some point it will say now it's enough. You have to do it now if you don't do it. So it's enforcing you to follow those all systems. So in a way, domain controller is one thing where you keep all the credentials, passwords, VPN passwords, keys to how you access devices and so on, all the passwords there. Then you got web servers, other servers, and then you got internal DMZ, web server emails. Now, again, we will be doing one exercise in tutorial to understand how to decide on which device to place where and why. So we'll do some exercise. I'm not going to detail that. But the whole point, now we got DMZ. Now DMZ is something that talk to the external world. So as a company, you have all kind of devices. Some devices that are internal, you don't really need to connect to internet. Nobody wants to fetch that data out of the country, out of your organization. But you might have some systems. For example, you have a website, you have a web server. Yeah, you have an email server. You want to interact with the external world. So you have email server. Those servers should be placed in a way they can interact with the external world. You have to be careful what kind of security will be there compared to other devices. I have a number of devices. I have 10 devices. My 9 of devices are not connected to the internet at all. I need not to worry about cybersecurity of those. But if one of the devices is connected, I'm worrying about. But I will also make sure that they are placed in a different zone. It should not be like that once attacker can connect one of the devices, this is connected to the internet, and then they can jump to the other devices if they're in the same network. But I will make sure that device is in a separate zone completely. So I know I need to take care of these devices which are connected to the internet, this zone rather than this zone. So it's a very kind of similar thing. So you decide on what part of the system is external to the world. So you want to have different security solutions and label for those, but then other devices which are not connected to the internet, you don't really care. Yeah, so that's how it looks like. So we call it level 0 physical process, level 1 intelligent devices, sensing, level 2 control system, and then you got manufacturing operation or supervisory operational system, operation management zone. Then we got a demilitarized zone, and this is kind of IT systems. Most of the IT system you do use VPN, or they have their own forcing encryption policies and so on. Now it is also called that cyber physical systems collect time series data. What is time series data? I'll be talking about all these terms because when we talk about the other lectures, I'm not talking about all these things then. I believe that you understand all this basic information, and then we talk about how to kind of what is the problem, what are the solutions, and so on. What is time series data? Simply sinusoidal, time series data simply says, I want to understand behavior of a variable over the time period. Yeah, I want to understand in 1 hour how many times stocks go up and down, for example. Similarly, you want to, and then frequency, current, voltage, they all go up and down throughout the day. So we want to understand how these values behave over a certain period of time. So I can get a sense in daytime, like peak time, I'm saying peak is my day, and then peak off in my night time. I want to understand what is the power requirement in day. What is the power requirement at night in this region or for this institute, for example. Time series data will help me to understand how you define day, how you define night, what is the hours, and then based on that you get to see what is the consumption level in daytime and in nighttime. So this will help you to understand time series data. Yeah, over the period you can then decide what period you want to analyze, and based on that you can do your analysis. There's something is called cross-sectional data, which says at this point I want to understand how many variables are impacting my system. Rather than over the period, I just wanted to know what is the condition now. What is the value of this variable at this point? Or how many variables are there that can impact my system as of now? Yeah, so that's the kind of basic difference that we see. Now, talking about the layers of cybersecurity. So generally there are 7 layers considered. Outer layer, very outer layer, human layer. Generally there's a saying called humans are the weakest link. Yeah, because it's easy to target human versus machine. If you put a code in machine which says don't allow X, Y, Z, it will not allow whatever happens. By humans, you can influence them. You can tell them a story, what happened, you show some pity, you create a scenario, this is what happened to me, show some sympathy and blah, blah, blah. Humans might influence and they may allow. That's one. And then in cybersecurity particularly, there's a saying like says, you target those people who are not cybersecurity experts. If you want to target an organization, you go to a receptionist, you go to people who really don't have understanding, but they're having system to use. You can influence them much easier because they don't have understanding what is phishing, what is spamming, what is what. Yeah. On the other hand, people who have some understanding, it's difficult because they will identify, they will apply some logic. So if you need to target an organization as an attacker, it's easy for you to target people who don't have cybersecurity expertise and customize them. And that's what I'm saying now. It's very difficult to detect those kind of attacks because attackers are customizing. They are planned attack now, organized crime, where they can customize the message. Even the experts cannot sometimes identify whether this is a phishing or spam. Yeah. Human layer, then you got perimeter security. What is the boundary of your infrastructure? How you're defining your boundary and what kind of security you want to have. Now we are talking about large scale systems. We can't protect countrywide infrastructure, it's impossible. Protection, security is all about costing. You want to place solution, how many solutions you can put in place across the country? So you have to identify what is your secure perimeter of the organization, how you're defining your, that's why there's a kind of importance of segmenting your network. Yeah, so that you know which part of the system is secure, which part of the system may be not secure, where you need more attention and so on. So you segregate it. Network security, mostly people, again, network security is not new. People have been talking about network security since very long. But now the behavior of the attack have been changed. Now they are more steal the attack. So let's say you have an intrusion detection which says if the payload is more than 1500 bytes or whatever, it will classify as an attack or threat. If the IP is coming up from one of the blacklisted IP, might be threat. Yeah. If the port number is open, whatever kind of basic IT that we used to do. The way this has changed is, as I said, now the attack is more sophisticated, more steal the attack. They know how to bypass. They are designed to bypass your IDS. So traditional method will not work. You need to apply a lot more intelligence than just the tool. Yeah. Endpoint security. Endpoint security simply, if I have a connection from here to there, I can put encryption over the network. So we know my whatever data I'm sending is encrypted. But how are the points? How are the devices which are sending and connecting data? If I'm introducing some data to this device, it can send my malicious data over the network in a secure way. And my malicious data will be received by the recipient. Yeah. So that's what is endpoint security. How you identify which of the devices or what part of the system having endpoint and what kind of security you have put in place today. Application security, depending on the number of applications you have, what data they are generating, you talk about data security. Now data security, we say data in transit, data in rest, data in motion. Yeah. When you're storing data, what kind of security you should have. When the data is being transmitted over the network, what security you want, and so on. And then you have mission critical assets. So within the large infrastructure, how you identify which of the assets are critical for you. You means infrastructure for your organizations. If I have 10,000 devices, I might not be in a position to secure all the devices. But what I will do, I will identify out of these 10,000 how many devices are there which are critical. If someone target those devices, if those devices don't work, how this will impact the physical operations. I will identify those devices and pay more attention to those devices rather than everything else. There might be one device. If someone attack it, I have a replacement. I have backup. I don't really care if you attack this, because maybe this part is isolated. Even if you connect all the devices, I still have backup. But there might be some devices which are really expensive, like servers, for example. You don't have many servers. Generally, university have organizations have 1 or 2 servers. What if you compromise the servers? You possibly are compromising all the data and so on. So we need to identify which are the critical devices and kind of thinking about how you protect it. Now, in terms of maturity models, I'll just go quickly now. One thing is called, so there are 4 levels. One say unprepared, reactive, proactive, anticipating. Unprepared, when somebody attack your organizations, you don't know what to do because you don't have security and control in place, or maybe you have just basic controls. And you don't understand what kind of attack it is, what is APT, and so on. Reactive says you have something in place. You react when someone attack. If no, you don't really care. Proactive says, I want to be prepared. I want to understand what kind of cyber risk my organization has, and I want to see what kind of security control I have. If someone attack with attack X, do I have a solution to this? If not, then possibly I would like to see how this will impact my organizations. If I can see there's a 10 attack that someone can target my system, out of these 10, I see how they impact my physical systems. If out of these 3 saying someone can control your brakes, someone can control your accelerator and attack, I should be more worried about those attacks rather than someone control your entertainment system. Yeah? So you decide on which are the more critical attacks to my organization, and I'm thinking about, do I have solution to this? Do I have enough tool technology to apply if someone attack like this? If no, I want to be proactive. I want to see what kind of solution I can bring in, deploy to my organization, which is more proactive. And then anticipating, like you prepare well structure for future as well. You're thinking your company is growing, you're deploying new devices and so on. So you're thinking in that perspective over the down 5 years, 10 years, how my system look like, what kind of security I will have. So you kind of anticipate about the futuristic of your system and then decide on solutions and so on. Let's skip this. Cyber hunting, again, it's been a difficult now. It's not been as traditional. Now we have, generally we call baseline normal behavior. So everything runs fine. I can see my voltage level should be this, my normal graph, yeah, for any variable. And then possibly you get to see new patterns. So maybe your IDS antivirus comes with some defined patterns, known attacks. And they come across with those, they can detect and flag saying there's an attack, there's a virus, there's a malware. But as we see every day, several thousand variations come every day. And there's also saying like antivirus companies also create malware so that they can sell their antivirus, isn't it? If their antivirus can secure the infrastructure, then there's no need to work on that. I'm not saying they are the one who do it, but there's a saying something like this. So then you can come up with new patterns, unknown attacks that you can't really understand, fluctuating your variable unexpectedly. Then there are certain tools that we need to use because they're having latest kind of technology. They handle large volume of data that manually we cannot do. Incident response, how are you going to react when system is under attack? Now more, I would say, effective incident response. So automating this process. When there's a malware attack my system, I should be, and it's changing some of the files, for example, running exe, that should not be done, should not be there, and so on. My system should automatically able to understand what's going on and triggers appropriate responses to fix those, or at least mitigate the impact immediately and alert people, operators, to look into this, what's going on. Because the companies or the massive attack, larger attack that we talk about on cyber physical systems, they've been coordinated in nature. Coordinated attack when someone is targeting multiple devices, multiple systems of your organization. They're not just targeting one device or one type of attack. There are multiple type of attack targeting different devices. So if you pay attention here, you won't be able to do it. So we need automated process that can sense things and then start doing to mitigate it as much as possible. Possibly visualization. So if there's an electrical operator, if you ask them, look at the files, look at the logs, look at the network PCAP file, yeah? Maybe he won't be able to understand because he's not trained with cybersecurity. If I give you electrical, I'll show you, by the way. But if I give you power measurements or the way it looks like, what is bus system and so on, if you're not trained, you won't be able to understand those things. So one of the things is visualize things in the way people can understand. Visualization is much better. If I show you a graph, it's easier, much easier for you to understand rather than if I start showing you quantities of where, voltage divided by current, I squared divided, some equations. It's very difficult to understand equations, and then rather than if I show you graph, it's much easier to understand. So in a similar thing. Okay, again, I'll skip all this. It will take time. So incident response, as I said, preparation, detection, containment, recovery, and post-incident activity. Most of the time from previous attacks, attacker were targeting the system, and because we don't have enough tools, effective tools, we end up by not doing anything, and there's only post-incident analysis that you can do. What happened to your system? You start looking at footprints that can help you to understand things. But then incident responses, you have to prepare in advance. You can't simply wait and watch situation. You have to prepare yourself, build your detection strategies around APT and more sophisticated attack. Think about how you're going to do recovery if system is down. So in one of the attacks, the system was down for over a month because it's not IT system. It's not like this has been attacked. You can bring new laptop and you connect it. It's all about those complex devices that are part of your routine. Yeah, and bringing those devices, configuring, calibrating those devices, connecting it to the right takes time. So what is your recovery plan when someone targets? And then there's also called cyber physical social system, where people want to understand how the data, not just sensors, but also from people perspective, social systems can actually influence the physical system. So again, this is an example of cyber physical energy system. So what you see here is, okay, I'll just go and talk about things. Now, when I say energy system, energy itself is a very broad sector. There are different types of energy, that part of it, and smart grid or power grid is one of those. So in order to reduce carbon emission, governments are introducing new way of generating energy. And one of the ways is renewable energy. What is renewable energy? That does not have carbon emission in a way, yeah? For example, we used to have petrol, diesel, coal, and so on. And they all generate a lot of carbon emission, which is not good for the environment. So they want to promote renewable energy, so that they say, oh, there's a solar energy, geothermal energy, wind energy, biomass energy, hydroelectronic energy, marine energy, and so on. So there are different ways of producing energy. However, these energy, we don't really know how much energy you can produce until you deploy and see. And how this can help. Obviously, year by year, our energy consumption is growing up. And the electricity that we generate as of now might not be enough. It's not enough as of now, but in the future. So there's a saying how you integrate different energy sources to the existing setup that we have, so that you generate, for example, wind energy, solar energy, and pass that to in one of the area as electricity and so on. Yeah. So how you can kind of reuse and send it to different part of the system as per the demand. Now, one of the difficulty is from cyber point of view, even if you are able to integrate, again, integration is another challenge, but we believe that at some point we have those solar systems, wind systems and all, and then somehow we are able to integrate all those into the centralized system. What about the cyber security? So currently we are talking about smart grid. We are just trying to understand how attacker can influence grid. Then in the future, we will be studying how attacker can influence solar system, a wind system. More importantly, integrated system. Is it possible attacker to go into a solar system and then target smart grid? Because they will be integrated in the future. Yeah, might be possible, but then understanding that how it's possible itself is too complex. So where we are heading towards are more complex systems. And it's not easy to understand operational side of it, and understanding cybersecurity is much difficult. In order to understand cybersecurity, you have to understand these systems, how they work, what devices they have, where the connections are, and so on. How these systems can impact each other. Yeah. So in the future, this will be a lot more complex system that we are talking about. And now we have, again, smart grid itself is as I say, countrywide infrastructure. So where we are kind of traveling towards much more complex systems. So definitely what we have learned in IT systems will not going to work here. We have to learn how we handle complex system, maybe a bottom-up approach, where you kind of have a bigger system and then you kind of divide and break down into small subsystems, try learn things, and then understand what are the interdependencies between those and so on. Yeah. So unfortunately, we don't have enough skills. Mostly people who work on cybersecurity, for them is like data security or IT security. Not many people understand these things. Therefore, it's really important to push these areas to do a lot more research, so that people can get into deep, do some experiments, give some better understanding. Should be feed into curriculum so that students from their undergrad, master can understand this is the future when you say smart city, smart systems. And then, because these are the sector will have a lot more opportunities in the future. If you are still working on web security, in the future you'll see a lot more jobs in this, and you are not skilled, you don't understand these systems. Yeah? Web security is already too crowded. I mean, the traditional IT system that people used to be. These are the systems will give you a lot more opportunities in the future. So it's really important for us to push ourselves and try understand interdisciplinary subjects more. Okay, just a few examples. So particularly in nuclear plant or a smart grid, you have something called physical layer. You go physical layer, where you have devices that are kind of being used to generate electricity. Then you got data acquisition layer. You got certain devices that control this part. And then you got servers that control this part. And then you have application layer where you can optimize and control things. So power generation, for example. So as I said, there are different sources through that you can generate power. But then power need to be transmitted across the country. It's a huge wise, country-wise thing. Power need to be transmitted from generation unit to a transmission substation. Have you seen the big towers in the field? Very big towers and wires going across, and it's saying it's too dangerous, don't 24,000 volts and so. And why it's like when electricity comes to our home, it's 220 volt, 240 volts. What does happen? How does it's been maintained? Why they have 24,000 and why we have 220, 240? I mean, we can understand might be the devices that we are using, they can't tolerate more voltage. That's why it's 220 or 110, whatever. Or why they have 24,000? Exactly. So from generation unit to transmission substation, they have to travel a lot more distance. If the voltage, what is voltage? It's all signal, travels in the form of signals. Higher the voltage, larger the distance they can travel. So they have to travel kilometers. If the voltage is really high, it can travel, and then you can capture that signal. Yeah, that's why those transmission lines are really high voltage lines, and you should not be touching them anywhere. And then it comes to distribution substation, where we got transformers, for example. It can step down the voltage as we need, and then be distributed to home, to businesses, and so on. So there are different devices. So let's say there's an attacker that can target your transformer. Your transformer is not able to step down the voltage. What will happen? It will blow out all the devices that you have. So these are the critical assets in the infrastructure. So we need to understand, and you'll be able to understand once you know what is transformer, how does it work, what's its role. Yeah. So there are other couple of other devices. Something is called PMU, phase measurement unit. That's the device that actually estimate the magnitude of voltage, current, and phase angle. I don't know if you studied those things, but kind of basic understanding. Then you got IEDs called intelligent electronic devices. These devices generally microprocessor-based controllers, and they are used for certain purposes. For example, transformers, circuit breakers, and other key operators. So PMU measure the data, IEDs control that data. And they got RTUs, remote terminal unit. Those are the units, they capture that data and then send it over the network to control center, for example. Yeah. So let's say I have 5 substations, yeah, where you got different transformer, they are sending data, passing current, voltage to different units, household unit, businesses, and so on. As a company, I have a control center. I want to control, I want to understand, because you got the same grid. Yeah? Distribution are different centers. You have different centers, but the actual power is coming from the one source. You are distributing. So you want to understand what is going on in your infrastructure. So that's why you have control center. Sitting at control center, you can analyze what's happening in this part of the system, in this substation, that substation, and so on. When someone attack your system, again, depending on how they are attacking, it might influence more than one substation. Yeah. So you have to have, this is what control center look like with the very large screens. You have seen that when they ISRO and they launch any new projects, you got to see the big screen where scientists are sitting looking at how it's big. In a very similar way, electrical operators, they look at the power quantities, which lines are getting overloaded, where's the more demand, less demand, so that they can manage the overall thing. IEDs, the way it looks like. Have you seen these? Maybe somewhere. Yeah. So these IEDs are for different purposes. For example, some to control relays, some to control transformers and others. And then you got different RTU devices. Now remote terminal units are the one they sends data from your substation to the control center. So all substations need to send data to the control center so that I can pass all the data to see what is the state of my system. Yeah. Now these devices run different protocols. Modbus is one of them. I'll talk about it in a minute. So then you got PLC. What is PLC? Programmable logic controller. What it does? It's a controller. You can put a logic, you can put a code, and it will execute on the basis of that. Yeah. For example, I can put it saying I'm sensing a data. If my data is kind of less than 50 hertz, it will pass, otherwise it will not pass. So you configure it, you can write a code in order to control the environment. Something is called SCADA system. What is SCADA? Supervisory control and data acquisition system. So this is part of your control center. So as I said, all the substations send their data by RTU. RTU will send it to the control center. Control center having a SCADA system. This will fetch all the data, run its algorithm, power algorithm. I'm not going to detail in this. And then based on that, it will decide what needs to be done. For example, in one of the areas, there's a huge demand of power. You need to take certain actions to fulfill that demand. You start providing that power from some other areas and so on. You connecting and disconnecting lines and so on. So you make those decisions once you're able to pass that data and get to see the big picture. Now power companies also do something called forecasting, load forecasting. So they are well prepared in advance. And generally they have kind of a 1 day ahead. Then they get a sense what's going to be demand for tomorrow and how they're going to fulfill that demand by whatever they have as today. For big events, for example, there's a Diwali fest. People will lighten up and so on, candles and so. There will be higher demand. So they're well prepared how to provide, how to meet that expectations ahead. Yeah. So for expected events, they might have forecasting. They can easily predict. Sometimes it's unpredictable. For example, COVID. There's a sudden drop of power at businesses, and there's a high spike at home. People were working from home. Those were unexpected for first few days, but then they get a sense. So you learn from historical data. So they learn from historical data to decide on what will be the demand on this time or this week, and they accordingly project how they will meet that demand. What operation, what decisions they need to make, and so on. Again, there are different systems: power system, water management, transportation, natural gas, nuclear, oil. They all are cyber-physical systems. Right. I'll just quickly jump one more slide. Now, connected components. There's a saying called connected autonomous vehicle. Now we know autonomous vehicle is called where we say driverless vehicle. Now driverless vehicle cannot run by its own on the road. It needs to know the environment. When you drive, generally you look for, when you overtake, you look for whether someone is coming on the right or not, whether there's a pedestrian or not, whether how's the route look like, whether the vehicle behind me or beside me is going to be autonomous vehicle. It's a driver-based vehicle. So you need that data as well as an autonomous vehicle. I'll be talking about autonomous vehicle in the lecture in more detail, but then we are talking about connected component. So that means your vehicle, obviously, currently your vehicle sends a lot of data within its, and this data has been sent to the manufacturer for improvement and so on. But then in reality, when you see the autonomous vehicle on the ground, we need to sense a lot of data, sending it to process, and that data will be broadcasted to all other vehicles so that they get a sense what does the environment look like around them. And then only they can survive, otherwise they will hit somebody. In a similar way, we have devices, some different type of devices. Maybe you are able, now you got mobile phone, different app where you can control your vehicle. Yeah? So all these things are interconnected, and once they've been attacked, one part of the system is attacked, there's always possibility it can influence the other part of the system. So I'm not scaring you, but the situation is, in order to come to a point where we say we have a smart city, it's not an easy thing. We have to learn things, we have to be skilled in order to control things, in order to maintain those things. It's not just about building things, it's about controlling things when they go wrong. If everything is working fine, you're fine, we don't care. When things go wrong, if you don't have control over it, it will destroy everything. Yeah? So I'll stop here, and we will continue tomorrow from here as well. Any questions, what we have gone through today? I think I just try to be more holistic, not going into more detail, but then give a sense out of it.